So, from the words of the title, you can see it's antiderivative, right? So how can we understand the antiderivative? It's a reverse action for what? Derivative, right? Antiderivative. Okay, so definition. We say a function capital F is called an antiderivative of a function lowercase f on an interval I if the derivative of capital F equals what? Lowercase f for all x in the interval I. Okay, so capital F is called antiderivative if we take derivative of what? Capital F. It equals what? Lowercase f. Okay, another theorem is telling us, okay, if capital F is an antiderivative of lowercase f on an interval I, then the most general antiderivative, okay, general antiderivative, okay, of f on this interval I is capital F plus this constant c, where c is an arbitrary constant. Okay, so now let's try to understand why capital F is called antiderivative of lowercase f. Okay, now let's use this function. Okay, yeah, this is table of antiderivative formulas. Okay, particular antiderivatives. So this column give us what? Lowercase f. Okay, this column give us what? Particular antiderivative. This column give us capital F. Okay, so these are the what? Antiderivatives of what? This given function f. Okay, so from the table we can tell that if a function f equals x to the nth power, where n cannot be -1, okay, its antiderivative is what? Particular antiderivative capital F is what? X to the n plus 1 over n plus 1. Why?
Professor, do you think occasionally that while going through these you could give examples? I'm sorry.
Yeah. So why is this x to the n plus 1's power over n plus 1 is an antiderivative of x to the nth power? Because by the definition, okay, by the definition of the antiderivative, when we take the derivative of capital F, what is the derivative of capital F? By using the power rule, okay, so x is a variable, n plus 1 is the exponent, this n plus 1 is on the bottom. What is the derivative of f prime? Can you tell me? Capital F prime. 1 over n plus 1 is a given 1 over n plus 1, right? What is the derivative of x to the n plus 1's power? Power rule, n plus 1 times by x to the what? N plus 1 minus 1 gives us what? N, right? So 1 over n plus 1 over 1 cancelled out, right? So eventually, what is the derivative for capital F? It is what? X to the nth power. So we say, because the derivative of f, capital F, equals this lowercase f, which is x to the nth power, then capital F is what? An antiderivative of lowercase f. Okay? You guys? Alright. Yeah, so later they're asking you, what is a function? A function f is an antiderivative of a another function. How? Why? Okay, when we compute the derivative of this capital F, it equals lowercase f. Then we say this capital F is an antiderivative of lowercase f. Okay? And then it says, okay, once we find capital F, which is called a particular antiderivative, okay, and then we add a constant c to this particular antiderivative, and then it will give us what? Most general antiderivative. Why? Because not only this capital F derivative equals what? Capital F derivative equals lowercase f. How about the capital F plus the constant c's derivative? Now let's still use this example. Because capital F plus constant c's derivative equals capital F plus what? The constant derivative. What is capital F's derivative? Lowercase f, right? What is a constant c's derivative? 0. See? Capital F plus constant c's derivative also equals f. So we say capital F plus c is also what? It is what? It is antiderivative, okay? And we call it is what? General antiderivative, because this c could be any real number. Could be any real number. Say you can let c equals 1. You can let c equals 0. You can let c equals -5. Okay? So it's a family of functions. Okay? So capital F plus c is called a general antiderivative of lowercase f. And then this capital F itself is called a particular antiderivative. You guys? Alright, and then this table is telling us, okay, if we have a function c times lowercase f, then 1 over the particular antiderivative will be c times capital F. Okay, f plus g, capital F plus capital G. Here we did this one. Okay, if a function it is equals x to the nth power, the antiderivative will be x to the n plus 1 over n plus 1. We just prove it. Why? Because the derivative of this equals what? X to the nth power, right? And then 1 over x powers, 1 over x, no, okay, not power, okay. 1 over x, this function's antiderivative is what? Ln absolute value of x. Why? Because the derivative of Ln absolute value of x equals what? 1 over x, right? 1 over x. And then e to the x antiderivative equals is what? E to the x. Because e to the x derivative is e to the x. B to the, what is this? B to the z. This is b to the z. Okay. And the derivative is b to the whatever x or z. It doesn't matter, okay? If we have a z here, this should be z, okay? Because b to the z's power divided by ln b's derivative equals b to the z's. Okay? So, yeah. Cosine x antiderivative is same. Why? Because sin of x derivative equals cosine, right? Sin of antiderivative is negative cosine, because negative cosine x derivative equals positive sin. Similarly, because the derivative of tangent gives us secant x squared. So that's why tangent of x is a particular antiderivative of secant x squared. Okay? Secant x times tangent, and the derivative is what? Secant x. 1 over square root of 1 minus x squared, and the derivative inverse same, right? Same function. 1 over 1 plus x squared, and the derivative is what? Inverse tangent of x. Okay? Yeah, so inverse tangent can also be written by arcsine, right? Yeah. Inverse can be written by arcsine. Inverse tangent can also be written by arctangent. So they are the same thing, okay? Same thing. So this table gives us the very classic, most often used, antiderivatives formulas, okay? Are we ready to do practice question? Example, find the most general antiderivative of the function and check the answer by differentiation. So, to find the most general antiderivative, eventually we have to add what? A constant c to our particular antiderivative, right? So, if a function lowercase f equals cube root of x plus 6 over x to the 6th power, how can we find the capital F? Are we able to use any formulas from the table? What? Excellent! Yes, right. Because cube root of x equals what? X to the 1/3. This is n is 1/3. Plus 6 over x to the 6th power can be written by 6 times by what? What is 1 over x to the 6th? X to the -6. You guys agree with that? So we have either n equals 1/3 or n equals what? -6, right? So what will be the antiderivative? Capital F. If n is 1/3, here the antiderivative should be what? 1 over n plus 1, right? Or 1 plus n times x to the what? n plus 1's power, right? So n is 1/3 in this problem, right? This is when n equals -6. So by using the antiderivative formula, right? Antiderivative should be what? 1 over what? n plus 1, right? Is 1/3 plus 1 times by x to the what? n plus 1's power. You agree with this, everybody? Okay? So this is, and then plus 6 times by, okay, x to the n's power, n equals -6 by the antiderivative formula, a should equals 1 over n plus 1, -6 plus 1, times x to the what? -6 plus 1, right? And because we want to find a general antiderivative, so we don't forget to add a constant c, right? So let's simplify. 1 over, what is 1/3 plus 1? 4/3? 1/3 plus 1, 4/3. Plus 6 times by, this is 1 over what? -6 plus 1 equals what? 5. X to the -5 plus constant c. We're not done yet. 1 over 4/3 equals, flip, right? 3/4. X to the 4/3. 6 times by 1 over -5. -6 over 5 times x to the -5th power, and then plus what? Constant c. You guys? But can we say this is indeed the antiderivative for this lower function f? How to prove that? By differentiate this function and see whether the derivative equals what? Lowercase f or not, right? Okay, so we're going to check on the side. Okay, we're going to check on the side. Okay, so how to check? Derivative of this, right? Over 4x to the 4/3 minus 6 over 5 x to the -5 plus c derivative. Over 4 times by, what is the derivative of x to the 4/3? Derivative. Derivative gives us n times by x n minus 1's power, right? So n is 4/3 times by x to the 4/3 minus 1 gives us what? 1/3. You agree with that, right? And then minus 6 over 5. What is the derivative for x to the -5? -5 minus 1, -6. What is the derivative for a constant? 0, I'm not, right that. So 3/4, 4/3 cancel out, we have x to the 1/3. -6 over 5 times by -5, negative, positive. 5 brings 5 cancel out, so plus 6 times by what? Is this the same function as lowercase f? Yes or no?
Yep.
Yes. X cube root of x is x to the 1/3 plus 6 over x to the 6. So yes or no? So yes. Okay. So we checked here. Okay. So that means this is indeed the most general antiderivative. Okay. You guys? Yeah, if it says, please find the most general antiderivative, don't forget to add a constant c, okay? If it says, just find a particular antiderivative, what do? We don't have to add the constant c, okay? You guys see that's good? All right. Now, for this question B and C, okay? Okay, so I want you to try these two by yourself, but I want to give you some hints, okay? For question B, if lowercase f of x equals this, how can we find the antiderivative? Do you want to simplify it first? Are we able to find the antiderivative directly from this fraction? I doubt it. Okay, it's too complicated, right? However, we can rewrite this lowercase f by what? 2x to the fourth power over x to the cube, right? Plus 4x to the cube divided by x to the cube, and minus 1 over what? Minus x over what? X to the cube. Splitting the three terms on the top and then let them divide by x to the cube, one by one, right? Do you see that? 2x to the fourth, 4x to the cube, negative x, right? Divided by x to the cube. And then let's see what we can get. What is 2x to the fourth over x to the cube? Yeah. Then x cubed over x cubed, 4. X over x to the cube, 1 over x squared, which is x to the negative 2's power. Right? Why am I writing this three terms like this? Because I want to use what? Power rules under the derivative, right? Power term, right? Power term. So I want you to finish this question, okay? Yeah, let's do it together, okay? It's not a hard question. So 2x, what is antiderivative? 2x. Think about what function's derivative equals to x? X squared, right? X squared. Or if you don't know how to do it this way. 2 times x to the first power, we know x to the first power, and the derivative should be what? 1 over 1 plus 1 times x to the 1 plus 1's power, right? So we say 2 is 2. X to the first power, and the derivative should be 1 over, this is n, right? N plus 1 times by x to the 1. N plus 1's power. You guys agree with that, right? And plus 4. What is first antiderivative? 4 can be written by 4 times 1, right? So what is 1's derivative? 1's antiderivative? X, right? Because x derivative equals 1, right? So this is 4 times by x. You agree with that, everybody? Yeah. So 1, constant 1, and the derivative is the variable itself, okay? Alright. Okay. So this is f of x, okay? This is f of x. Now we're talking about capital F of x. We're computing antiderivative, okay? Antiderivative. So capital F equals, okay. Alright, so what is x to the negative 2 antiderivative? 1 over n plus 1 times x to the n plus 1's power. Don't forget to plus the constant c, right?
How did you get that to be plus x to the negative 2?
Plus x to the negative 2.
Yeah, because it was to be a vector. It's minus x. When you're in the original, it's minus x over x cubed.
Okay.
So how did you get
Yeah.
that to be addition?
So x over x to the cube should be 1 over x squared, right?
Right.
What is 1 over x squared?
No, I know that it's
Yeah.
supposed to be negative 2, but why are you now adding it instead of subtracting it?
Oh, yes, you're right. This is double. Thank you. Yeah, I should be subtract, okay? Should be subtract. You're right. Because we're, 1 over x squared is actually negative 2, but we're subtracting that. Yeah, you're right. So here, if we copy the negative sign, it's going to be negative. Thanks so much for reminding me. Okay, if I did anything wrong, let me know, okay? Sounds good here? Everybody know what Brittany was talking about, right? Alright, so the calculation, each term has no problem, but just the sign, it has to be negative. Yeah, you're right. Alright, so 2 times by 1 over 2, 1 plus 1 is what? 1/2. X to the 1 plus 1 is what? 2. Plus 4x minus, what is negative 2 plus 1? negative 1, right? So 1 over negative 1 is negative 1, and this is negative. Now it becomes what? Positive. You guys agree with that? Negative 1 over negative 2 plus 1, this thing is positive 1, okay? And then x to the what? Negative 1's power plus c. You can keep this negative exponent there, or you can rewrite this as 1 over x either way, okay, either way. However, 2 times 1/2 is gone, so eventually answer is x squared plus 4x plus x to the negative 1 plus c. How to check whether this is correct or wrong? Differentiate this result and see whether you can get lowercase f or not, okay? Any question from this question too? No? See, we're keeping using what? Keeping using the formula, right, from the table, okay? So, lowercase f, oh, there will be corresponding capital F, just use the formula, okay? Alright, question C. If a function r of theta is defined by secant times tangent minus 2 times e to the theta, find the most general antiderivative.
Is it secant theta minus 2 e theta plus c?
Yeah, okay. So lowercase r, antiderivative should be capital R of theta. What do you say, Grant? What is antiderivative for this?
Secant.
Secant theta. Right, it's telling us, right? Secant x, tangent x, antiderivative is secant x, right?
One I memorized.
Yeah, okay. So secant theta, okay? And minus 2 times y. What is antiderivative for e to the theta? E to the theta, right? So e to the theta and plus 1. Cos of theta. Done. See? Easy question, right? Alright, so now let's move on to the next page. Okay. Find lowercase f. If the derivative of f is given by this, and then also we know lowercase f of 1 equals 0. Here, this lowercase f is what? The antiderivative of what? F prime. You guys agree with that? Okay? Because lowercase f's derivative equals this. Okay? So that means to find the lowercase f is the same thing as to find the antiderivative of what? This function. You guys agree with this? Alright, so what is antiderivative of 4 over 1 plus t squared? Oh, where is this is t? This is typo. F prime of t, okay? We have to make sure that there's only one independent variable, okay? F prime of t equals 4 over 1 plus t squared. Find f such that f prime of t equals this, f of 1 equals 0. So, what is the most general antiderivative of this function?
2t to the negative first.
Okay, so 4 over 1 plus t squared, do you have any formulas in the table telling us? Power rule.
Yeah, because we can change it to 4t to the negative.
Can we split 4 over 1 plus t squared by this? Yes or no? No.
I thought that was a multiplication symbol.
No, yeah. Only when we have one term on the denominator, then we can split. Okay? But if we have multiple terms on the denominator, we're not splitting the fractions like this. So we have to consider the 1 plus t squared as a whole thing, right? However, how about 4 divided by 1 plus t squared can be written by 4 times by 1 over 1 plus t squared. What do you think? Do you have any derivative for 1 over 1 plus t squared? 1 over 1 plus x squared gives us what? Inverse tangent of x.
Is it possible that we could have that table on our formula sheet?
Yes! Yes, you can. Copy things down on your formula sheet to help you. 1 over 1 plus t squared, and the derivative is what? Inverse tangent of t, okay? So, I would say f of t should equals what? 4 times by inverse tangent of t, okay? However, we have to add a c, constant c, okay? This is the most general other derivative, okay? Okay, can we see we're down here? This is, we're already finding f of t? Not yet. F of 1 has to equals what? 0, okay? So by using this condition, we're going to compute what? The c value. After that, we're going to plug in the c value back to this function f, right? So when x equals 1, or t equals 1, f equals what? 0. So tangent inverse of 1
Is,
plus c. Yes. So what is inverse tangent of 1? What does inverse tangent of 1 mean? Tangent of what equals 1? This is idea for tangent inverse of 1. For what angle of x such that tangent of this angle equals 1? For what angle? Pi 4, right? Pi over 4, right? So pi over 4, right? Everybody? So, because tangent of pi over 4 equals 1, so inverse tangent of 1 equals pi over 4. Okay, so inverse tangent of 1 equals pi over 4. So 0 equals 4 times by pi over 4 plus the constant c. So pi plus c equals 0. So c should equal what? Negative pi. Okay, now we're going to plug in negative pi back to this function f. So I will say thus, okay, f of t equals what? 4 times inverse tangent of t plus c. What is c? Minus pi. Okay, so this function f satisfies the derivative of the function equals what? 4 over 1 plus t squared. Also, when we replace t by what? 1, f equals what? 0. Okay. Any question from this question? No? Okay, good. Alright. Our last question. Still when you find lowercase f such that the derivative of lowercase f equals this, and also f of pi third equals what? 4. Okay, so this t value must be between negative pi halves to pi halves. So to find any derivative, right? F of t should equals, what is any derivative for this function? Cosine function, any derivative, check the table. Same, right? So 2 sin of t, secant t squared, what is any derivative? Plus constant c, right? Oh, this function f must satisfy when t equals pi third, f equals 4. Sin of pi third plus tangent of pi third plus c equals 4, right? So you have to know, oh, for those special angles, right, what are the values for those trig functions? Okay. What is sin of pi third? What?
3 pi over 2. Oh, 3, probably root 3 over 2.
Yeah, root 3 over 2. With tangent of pi third. Tangent of pi over 6 equals square 3 over 3, right? Remember that? And tangent of pi third gives us square root of 3, okay? And then plus the constant c. So 2 cancel out. So 4 equals 2 times square 3 plus c. So subtract by, 2 square 3 from both sides. c equals 4 minus 2 square root of 3. Okay, so that's why we say eventually, okay, thus f of t equals what? 2 times sin of t plus tangent of t plus what? 4 minus 2 square root of 3. This function f satisfies the derivative equals this, you can check, okay? And also, when t equals what? Pi third, f equals what? 4.